So this is section 7, just talking about the resource and assessment of the topic portfolio. So just to start off with the resources part, I've made a few different resources because it was kind of difficult to just make one fits all. So I have 3 different parts there, just covering key parts and the key principles of dynamic mechanisms and linkages. So just to start off with, this is just a quick model here that I put together in one of the labs early in the semester, and it's very simple to make. It would be easy to make in a classroom. If you had a double class, you could definitely get it made, and students could be trying them out in the first class, and you could get on to covering the topic then in the second. And basically just the circle rotates around here. You just get a pin or a nail or something and rotate around the circle, and it travels along this sliding link here, and depending on how far you move it back or whatever, it has a different point along here, along that path there, and it's just kind of to get the students familiarising what they're actually looking at. Then moving on, this worksheet here just covers this is kind of just a quick one. Maybe you could do it in the first lesson, just get them familiar with reflection, rotation and translations. So this is kind of your draftsmanship and marking off measurements, so improving your compass skills, which is an important part for this topic, especially because you have a lot to do with compass in it. Then the third one there, this is I made this after getting feedback in one of the labs from one of my peers, and they were saying they didn't have this topic for their portfolio, so they didn't really understand where this circle was coming from. So I just made, on SolidWorks, I just made this quick linkage here, and just basically to show where we actually get this circle, and it's just the path that this travels around. I have a quick video there attached for it. Then moving on to the assessment then, this is just a quick crank here. So you have 2 different circles here, and one is going clockwise, one's going anti-clockwise, and it's just kind of it's a crank with a fixture link. So we're going to be plotting the locus of P here, and so for the questions, just for that, like what type of link mechanism, so you have, as we said there, crank through link. Then this is to get them thinking about the method used to find this. So they would have really started off with the Trammell method, would have been the easiest one, and this is kind of just get them thinking that the dividing circles into 12 is probably a lot easier, because it kind of gets a bit messy when you have a lot of moving parts in them, and it's kind of hard to mark off like which point goes where at the Trammell. And then the next part of this question is to name another type of link mechanism and just a brief description of it. So just for example here, I did one out on just a sliding link mechanism with a Trammell. So it's just very briefly there how like you have to keep with your Trammell, A stays along A, B stays along B, and you just plot P in the middle to get the trace of it. Then 5 is kind of a main one for like hard to understand in DCG, so you kind of relate them back to everyday examples. So just asking for a real example of that type of linkage here in the question. So we have it completed here, and just kind of anything we really do, but these old type of trains where, well, these are anti-clockwise and clockwise, but they're both moving together in the same direction, but it's just the way how this link is moving them together in the same direction. And it's just to get students thinking about where they can actually picture these type of questions in their everyday lives.